So here understand the question, what is given in the question, and then we will also solve the question. Okay, what is given? A non-homogeneous ladder. Okay, now if you consider this ladder, this is non-homogeneous. Non-homogeneous means what? The material distribution is not perfect. Okay, there could be some impurity in the material, and material distribution is not perfect. That is why if you consider the center of gravity of this ladder, see the what is the length of the ladder? 2 plus 2.5, total is 4.5. So what will be the center of the ladder? This will be how much? 2.25, right? But you see the weight is not acting at 2.25, it is acting at 2 meter. Why is that? Because the given ladder is non-homogeneous ladder. What is meaning of this? The material is single material is not there. It could be it could be there. That could be the problem, and because of that the center of gravity might have shifted. Okay, so same thing has been shown over here. Now this ladder is being rested at point A. It is having support with vertical wall, and at point B it is having support against the horizontal floor. Okay, so we'll move ahead. Rest against a smooth wall. So at point A the wall is smooth, meaning here friction will be what? 0. Okay, smooth means mu value is not given, so friction will be what? Friction will be 0. Now this question is very important. ठीक है, understand करो अच्छे से. And a rough horizontal floor at B. So this point is rough, meaning here friction is there. The mass of the ladder is 30 kg. So this W value will be 30 into 9.81. Okay, so I'll keep the diagram here again. So this W value is 30 into 9.81 Newton. Then next is concentrated at 2 meter from bottom. Why is this? Because this ladder is non-homogeneous, otherwise it would have been 2.25 meter. The coefficient of static friction between the ladder and the floor. So between the ladder and the floor, this coefficient of friction has been given 0.35. Will the ladder stand in 60-degree position as shown? Now this problem can be solved by 3 methods. Okay, there are 3 methods to solve the problem. We'll solve by all the 3 methods. Okay, first method is by comparing the coefficient of friction mu value. Okay, now mu value is given in the question. We will behave as if that mu value is not given. So we will find the mu and we will compare it with the given mu. That will be the first method. So I'll write down method 1. It will be comparing coefficient of friction mu. Okay, now since the ladder is going to sleep, this point B in this direction, friction force will be towards right. So I'll show the friction force. Friction force will be towards right. Normal reaction is perpendicular to the surface. So normal reaction at this location will be suppose NB, and the friction force is we are considering that we have to find mu value to compare. So I'm going to keep this value as mu only. Okay, so it will be unknown. See, either you can solve this question considering mu as unknown, or you can consider theta as unknown. This is second method, and one more method is there where we can find friction force and we can compare it with by F max. Okay, we have seen that graph, that like this graph is there, effort P versus the friction force. So here we have F max. So we can compare the given F with F max and find whether the ladder is in equilibrium or whether it will move or it will slide. Okay, these are the 3 methods. So first we are going to compare mu. So here what I will show, this will remain mu into NB. Okay, even though mu value is known, I'll consider this mu as unknown so that I can compare whatever mu I am getting over here with this 0.35. Okay, then point A, it is slipping in downward direction, but at point A mu is not given, it is smooth surface. Okay, so what I will do now, I will consider the condition of equilibrium. First condition I'll take summation of moment about point B is equal to 0. Okay, so if I take this one, see now W is acting in downward direction with respect to point B. So it is creating which moment? Clockwise. And we require this perpendicular distance. Now this is the adjacent side of this 60 degree. So adjacent side is cos. So this adjacent side will be 2 cos 60. Okay. And if you consider moment about point B, moment of mu NB and moment of NB will be 0. So I'll consider first the moment of W. It is clockwise. So minus W into 2 cos 60. This is moment of W force. Okay, and the W value we already know. What is that W value? Minus 30 into 9.81. Okay, next at point A, okay, I don't have the friction force, but I have normal reaction. So I'll show the normal reaction at point A. Okay, so this will be normal reaction given by the wall on the ladder. Okay, now when I'm drawing the FBD, you have to understand that I have to remove this support. Okay, I am removing this support. Okay, that I am not showing over here. So this will be Na value. Now what is the moment of Na about point B? It is clockwise or anti-clockwise? It is anti-clockwise. And what is this distance? It is opposite of this 60 degree. So opposite means it will be sine. Okay, so opposite side will be this total, which is 4.5 sine 60. Okay, and since it is anti-clockwise, it is positive. So plus Na into 4.5 sine 60. This value is equal to 0. Now only unknown over here is Na. So I can find Na. Na is equal to, what is the value you are getting? 75.52 Newton. This is value of Na which I am getting. Now I will use some other condition of equilibrium. Summation of all the forces in y direction equal to 0. Okay, why? Because see, we have three conditions of equilibrium. This is general force system, this is coplanar. Okay, non-concurrent, all the forces are not passing through one point. These are non-parallel forces. So this is general force system. So summation of moment about a point equal to 0, summation Fy equal to 0, summation Fx equal to 0. These are the three conditions of equilibrium which we have to use. So summation of Fy equal to 0. What will be this value? Nb is upward, so plus Nb. Then W is downward, so minus 30 into 9.81. And any other force we have? No, we don't. I don't think we have any other force. Okay, this is equal to 0. So NB comes out to be 294.3 Newton. Now I will use third condition of equilibrium, summation of all the forces in x direction equal to 0. So towards right I will take positive, towards left I will take negative. Okay, so mu into NB is towards right. So plus mu into NB is 294.3. Next one, Na is towards left, so minus Na, and Na value is 75.52 Newton equal to 0. So only unknown over here is mu, coefficient of friction. Mu is equal to 0.2566. Okay, this value of mu I am getting after solving the question. Okay, now if you consider the given value, okay, I'll write down the concluding remarks. Since mu is equal to 0.35, this is the given value, okay, which is greater than 0.2566. What will happen? Ladder will stand. the coefficient of static friction between the ladder and the floor is given. Will the ladder stand in 60-degree position? This is asked. Okay, now what I have done over here, see, the maximum coefficient, the coefficient of friction given is how much? 0.35. Okay, now what is the coefficient of friction required so that the ladder will stand? It is 0.2566, and given value is greater than that. That is why the ladder is going to stand. Okay, now one more method I will solve. Method 2. Comparing F and F max. Okay, so what is F? Friction force. It will be equal to mu. Okay, what is that value? Let me check. It is mu into NB. Okay, so friction force is mu into NB. 2566 into NB. We have found out what is value of NB, 294.3. This is 75.51 Newton. Okay, next I will find F max. F max is equal to mu into NB. Now this mu will be mu given, which is 0.35 into NB remains same, 294.3. So if I find this value, this comes out to be 103.005 Newton. Now if you remember the graph, I had shown a graph during a theory session like this. On y-axis I have F, and on x-axis I have effort P. Okay, so what happens? Initially the graph is like this, then the graph becomes like this. Okay, so here this value is F max, and whatever we have found, that value is F. So in this region, this is basically the static region. Static equilibrium is there, and beyond this there will be motion to the body. So if you consider this, the given force, from the given mu, whatever we are getting the F value, that we have to consider as F max, and whatever value we are getting, okay, that is 0.2566 into NB that we are getting. This is the force right now which is being acted on the ladder, but since the mu value is greater than that in actual case, this is the F max value which is there. Okay, so if you compare F and F max, F is less than F max. So from here also we can conclude that the ladder will stand. Since F is less than F max, ladder will stand. This is the effort P required to move the block. Okay, now the maximum friction force is suppose F max. Okay, so if P is 0, friction force is 0. If P is 30, friction force is 30. Now suppose F max value is 90. Okay, so when P value reaches 90, then the friction force is also 90 and the body is in verge of motion towards right. Okay, now when the P overcomes this F max, then only the body will move. So same thing is written here, na? So P or whatever the given force F, friction force, it is less than the F max. So F is less than F max, so body is in equilibrium. I mean, body is stationary and it is in equilibrium. Did you understand this now? Now third method is method by comparing theta. Comparing theta. Same problem we are solving by three methods. Okay, now what I will do in these equations, whatever equations are written over here, same equations I am going to use. Okay, now instead of finding mu, substitute the mu value wherever it is required. Okay, but what I will do, here it is required, right, mu value. So I'll take this value as 0.35. But what I am going to do is I am going to find what is this angle theta. Here the angle theta is given as 60. So everywhere the theta value I'll take it as unknown. So I'll copy all the things as it is. Okay, same way. Only thing is what? Only change is what I'll explain you. Okay, so all the method will, all the procedure will remain same. Equation will remain same. Only what I will do, instead of taking that angle, okay, instead of taking this angle as 60 degree, I'll take that angle as theta. It is unknown, and I'll try to find that theta and I'll compare it with the given 60 degree. Now if the theta which I am getting, okay, if it is greater than 60, then ladder will slip or stand. That theta will be for equilibrium. Okay, agar theta is suppose 70 degree, for example. Okay, theta is 70 degree, and suppose I am getting this angle as 60, or given angle is 60, so ladder will stand or slip? Ladder will slip, because the angle is less, na? So if angle is less, it will slip easily. If angle is more, it will not slip. Okay, so same thing is there. What I will do, instead of at each and every location wherever this 60 is there, I'll erase that, and instead of that 60, I'll keep this value as theta only. Okay, same way, so I won't be getting this value. Same way for this one, if I use this equation, I'll get NB value, I'll get the same value of NB, 294.3 Newton. And in this equation now, instead of keeping this mu as unknown, I'll keep this mu as 0.35, which is given in the question. Okay, and here this value Na will be unknown, so I'll keep this value as Na. See, that equation I had Na. Okay, this value, this is summation fx, right? So in summation fx I have negative Na, so that negative Na I have to write over here. So this value is negative Na. So from here I can find Na value, which is equal to 103.005 Newton. And if I substitute this Na value in this equation, I can find the value of theta. Okay, so theta value I will get as 51.77 degree. Okay, now for the concluding remarks, how I will write? For equilibrium, theta value should be how much? 51.77 degree angle is required. Okay, now here you need to understand this logic properly. Okay, the diagram is shown in this way, right? I'll show the diagram in this way. This is the ladder. Okay, now for equilibrium, this angle is how much? 51.77 degree. Now if I reduce the angle of the ladder like this, suppose I keep, this ladder will slip. Okay, and if I increase the angle, okay, I'll show the diagram over here. If I keep it like this, okay, this ladder will not slip. Okay, now what is the given angle? Given angle is in the diagram. What is the angle given? The ladder is standing at 60 degree. Okay, now this given theta is equal to 60 degree, that is given as shown by green color over here. It is greater than theta, which is required to hold the ladder in equilibrium, is greater than 51.77 degree. That is why, therefore, ladder will stand. See what happens, suppose I decrease the angle over here. Okay, if I'm decreasing the angle, the ladder will easily slip. Okay, but if I increase the angle, the ladder will not slip. That is the logic over here which you need to understand. ये समझा आप लोगों को? हाँ. So these are the three methods. What is the first method which we have seen? Okay, even though mu is given in the question, okay, even though mu is given, what we have done, we have calculated the mu and compared the mu. This is the first method to find whether the ladder will stand or sleep. The second method is we are going to compare the f max value, and third method is we are going to consider that the theta is the angle is unknown theta, and we are going to compare that theta with this 60° given in the question. Okay, and in that way also we can find whether the ladder will stand or sleep. So these three methods we have.